Doc here with the last part of our review for the first lab exam in the physics of sound and music, Lab 5, Frequency Modulation. What is frequency modulation? Well, frequency modulation refers to modulating the frequency, and remember modulation means change. Change the frequency. When is frequency modulation a vibrato? When the pitch does not change that much. So you can think of the sweep of the pitch. It has to stay close to the pitch that you're on, and also a human is going to be doing this, and when a human does a vibrato from the lab, we learned by measuring Joan Baez and other vibratos that the vibrato frequency is 6. So the 6 hertz is the frequency of your vibrato. That should be memorized. That's a good number to keep in your head. So if you're going very, very much faster than that, like 12 hertz, that's not going to be a vibrato. And if you're doing 6 hertz, but you're sweeping up like a siren all the way up an octave or back, that's not a vibrato also. So to have a vibrato, you have to have a 6 hertz change that doesn't change the frequency that much. So it's more of a quiver. So the sweep frequency modulation and the symmetric, let's look at what those things are. When you look at a carrier wave here we have carrier wave that's doing some kind of modulation. Let's go ahead and study these. First, take the frequency of modulation, either one, off. There's 2 frequency modulators here going on, and I have them both turned off. So for the first type of modulation to discuss is this one called the sweep. What the sweep does, it takes this carrier frequency and then increases it, and sweeps it up and brings it back again. That's what this does. So it takes that, and we'll go ahead here with the triangle. There you go. So the triangle here, it takes this pitch here, and by sweeping it higher pitches, it makes the wavelength shorter, and then it puts it back again. This puts it back to where it is. See there. Now your symmetric one squeezes and stretches it where this is the center value. So here, you see, we go to a shorter wavelength and a longer one relative to this one. So just think of this one's in the middle. Then I go shorter and I go longer. All right. Here, this is at the extreme, this long wavelength, and then when I do the modulation, I get shorter, 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 and go back to the base. I do not stretch it more than what the base happened to be at the beginning. So that's your sweep. So you can think of the sweep like if you start at a, say, this is 500 hertz, all right, carrier. So 500 hertz carrier. If I sweep, I'll go higher and higher, higher and higher, say 600, go back to 500, go up to 600, go back to 500, go up to 600 or 700 or 800 or whatever, and go back. If I have symmetric, I'm going like 505, 495. See, I'm going a little bit on each end. So for a vibrato, you'll be doing a symmetric, a quiver. And if you quiver and go and sweep up and down again, you get some kind of Halloween scary sound. And that's both working together. Experiment and have some fun and see if you can get here a sweep going on with a quiver superimposed. In other words, two vibratos going on at the same time. See, that's quite neat to do. See, so here I have a little quiver that's sweeping to a higher pitch and back to a lower pitch, but it's actually quivering about at the same time. So we have here what kinds of sounds can be approximated with frequency modulation. Well, they would be like here is your siren, sirens, let's say a sliding whistle. In fact, there's a nice little chart on your power notes. Here's where your power notes might be nice to check out, because there was that little table of 3 by 3, 9 things, and they were all frequency modulation. So be sure to check that and look at all those cases. And there we had the carrier was low, medium, and high. Remember, carrier means sounds that you can hear. So low is like bass notes, and then medium would be like in the middle of the piano, and then like high would be like really beyond the piano, like bird sounds, really high up there. And then for the modulator, remember modulator goes from basically like 0 to like 20 hertz. That would be this control here. See, 20 hertz, and then here, well, we don't go to 0, but 0.2. So remember, 0.2 hertz here at the low end corresponds to a period of 1 over 0.2, which is 5 seconds. So what can slowing a sound excerpt down be used in measuring vibrato? Okay, what we did there is we looked at like some singers. For example, here, Kim Crosby. And like what you do is you well, you know the answer is like 6 hertz, all right, but it's hard to kind of hear 6 hertz. So like you stretch the time. So you may hear her 6 things like, oh, oh. It might take like 6 seconds, because you stretch the time. But then when you push it back, you would then get, if it did it like 6 times in 6 seconds, but you want to stretch it back, push it back, then it's 6 times per second, and that's how we measured it. So we basically stretched the time, and then so we can count them, and then we pushed it back. It would be instructive for you to do 1 or 2 of those over again in the lab, and make sure that you can do that. There was another question related, like, for example, if it takes me twice as long to walk to the wall, say, in other words, I stretch the time, what I have to do with my velocity, I have to slow down, just like the singer is slowing down sort of the vibration. So then if you want to know here, if I walk to the wall, quickly, then that's going to take half the time, see, because if I stretch the time, and take, say, 10 seconds to walk to the wall, because slow motion, then I would get to the wall in 5 seconds if I walked, say, the regular speed. Then we would say your speed has to double to get like the real speed, because in slow motion it would be taking you twice as long. Those things are best done by looking at a couple of those questions over again that involve measuring the vibrato. That's the best advice I could give you there. And if you can answer the question right the first time without guessing, you're prepared for the exam. What effects different modulator have on the different, let's say, carrier waves? That's the same game we played earlier with here, picking different ones. This is your European siren, kind of beep, 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 beep kind of thing. And the Americans were like going up and down. There would be, let's see, different waveforms and frequency modulation. Let's just look around here, skip around to see what else might come up that might be useful. Yeah, this one here is good. We saw this already with the amplitude modulation case. Here you're applying it to frequency, so you have an accordion effect. You're stretching and squeezing instead of playing with the amplitude. So here, just remember what we did before. If you count, say, 10 of these for one cycle there, then this is going 10 times the frequency here, and this is 10 times longer than the wavelengths there. I would recommend doing a couple of those again, since they're very, very short and quick to do. What are some ways of achieving frequency modulation using the numbers in a table? Here you don't have to remember these rules. I'll tell you. I'll tell you the rule. The rule that we use here, there were 2 of them, but they'll be told to you. Sometimes we just multiply the number and we're finished. Other times you multiply this number and then add to it. So if you multiply, let's say 0.1 times 100, if that was the rule, then you'd be finished. It's 10, all right? But if the rule is multiply this and then add it on, then it's 110, see? So that will be told to you during the exam question. And if not, raise your hand. Make sure that you understand, what rule we're applying. But here we're changing the frequency. And remember the way to do the amplitude on these things. If you're going here to 0.1 above the axis and minus 0.1 below, amplitude's 0.1. Another way to do it is to consider the very, very bottom minus 0.1 and climb up to the top of the hill, and that's 0.1. You'd climb up 0.2. So you would go 0.1 and get the equilibrium and 0.1. So sometimes it's easier to do that and get the 0.2 and divide by 2. So either that way or just simply look for the value above equilibrium. But sometimes all the numbers are positive. If all the numbers are positive, then you want to go from 0 to that top value, which may be 4, say, and then divide by 2 to get your amplitude. I think that does it. What are the effects when different frequencies? We did that. I think we're good. We're good. Good luck on the exam.